So now we have to find another one. So what equation do you want to use? Still, sum of the forces in the x doesn't help. How about sum of the moments about F? Because that cancels these two out, and that, and that. Oh, that's a great equation. We should have started with that one. Sum of the forces at, sum of the moments at F. This cancels, this cancels, this cancels, this cancels. Oh, this one's a good one. 100 times 6 negative, and then CD times 8 positive equals 0, and CD turns out to be 6/8 of 1,000. What's that?
750.
750 pounds equals CD, and we got a positive value, so what does that mean? Tension. And now what do you want to do? How about sum of the forces in the x? CD negative minus FG minus 3/5 CF equals 0, and FG turns out to be I got 7,500. And I got a positive. Did you get that too?
I haven't checked yet.
Okay. So 3/5 of 2,500, that'd be 1,500. That'd be a positive though. 1,500. 1,500. Yeah, that's it.
Okay.
Do you see another point we could have found a moment about?
Yeah.
There's this virtual point up here, right? Point C, that we don't really see in this portion of the truss, but CD goes to it and FC goes to it. So you could do a sum of the moments about point C, and these two would cancel. And then you could solve for FG. So it doesn't have to be the points that are on the truss, it could be virtual points as well. So in this particular problem, you didn't have to find the values of all the members. You only needed to find some. So figure out, put a line, mark up the ones you needed to find, and it seems like, wow, yeah, let's just section this truss into two parts. And like I said, we could have done the left or the right, but I did the right. And then I found out what those three forces are, because once you break them, they become external forces. But I could have done method of joints. I could have went to, let's try doing method of joints. We could have started at joint E, and from two equations, I could have found this one and this one, right? Then, could I have gone to joint F? So let's think about that. I started with E, I found this, and then I went to F. Can I solve for these other three unknowns? No, because I only have two equations. Oh, actually, yeah, because I only have two equations. I only have, because all these members are coming in at the same point, they're all concurrent, there can only be translational motion, and I only have two equations. And I can't find three unknowns with two equations. So after joint E, I would have had to go to joint D. And then I could find this guy, and this one I needed. And then I could go to this joint, because now I know this, and I could find this and this. But it would have just been 3 steps, with 2 equations each step. So that would have been 6 total steps. Where here, I sectioned the truss off, and I only had 3 steps, 3 equations to find it. Wouldn't you say that method of joints is kind of like a method of sections? Because if I divide it here, aren't I sectioning off my truss? I'm doing a method of joint, but I'm really looking at a section of the truss. And that's the same thing when I look at this joint. I'm really just taking this portion of the truss out. It is called method of joints, but it is also a section. I'm just looking at a section of it. The idea is that whenever you break something, it becomes an external load, and then you could calculate what it is. Okay, so that's it. So summary, trusses. First thing you do, you take the whole structure and move it away from its main supports. But actually, for this problem, did I need to know what AX and AY were? Did I use AX and AY in my solution? No, because I did the method of sections. Because I chose the method of sections, I only needed to find one side. So when you know you're going to do sections, you might only need to find one side. You don't need the other side. If you chose the left side, you would have needed these two and not this. So even though the first step in solving a truss problem is to take the whole structure away from its main supports, you may not need to know what all those supports are. Once you, whether it's a method of joints or method of sections, you take the whole structure away from its main supports, find the reactions at that support, choose whether you want to do joints or sections based on what they're asking you, and take a look at them, make sure that you know, you isolate, you find out which ones are zero force members, because that's going to decrease your solution. If I didn't know that CG was 0, I might have had to break it like this instead, and then break it twice. But because I knew this was 0, I didn't have to break it here. I already knew it was 0. So then you decide joints or sections. And then the key thing that I find that people forget to do at the end is once you solve for the members, you have to remember to write down whether they're tension or compression. So they have a value and they have tension or compression. Okay, that's trusses.